Welcome to the lecture devoted to transport protocols. These are protocols operating in the fourth and the fifth layers of the OSI model. This module will be devoted to the risks connected to these protocols and the ways of mitigating them. The fourth layer, or transport layer, consists of two protocols widely used in computer protocol networks. These are the TCP and UDP protocols. Both are responsible for bidirectional communication. However, they differ in how they work and in the functions that they perform. Why do we need the transport layer above the network layer? One host can run more than one program on one network service. This is usually so. Frequently, you use an email client, internet messenger, etc. simultaneously. All of them work on the same host. All of them will be identified by the same sender IP. There must be a way then to differentiate the packets. There must be a way to direct responses to corresponding programs. Your emails shouldn't be received by the web browser and websites by the messenger. This is where the transport layer and the TCP and UDP protocols come into play. These protocols allow us to unambiguously identify communication endpoints, or sockets. Individual sockets consist of an IP address, a name of a transfer layer protocol, such as TCP or UDP, and a port number. One port can only be used by one program at a time. It's more convenient when a given service is permanently assigned to a given port. Therefore, it's customary that low port numbers, lower than 1024, are assigned to specific services. For example, an HTTP server listens on port 80 for TCP client requests, and port 443 is used by HTTPS protocol. This is only a convention. Nothing obliges the packet sender or receiver to use specific ports. And that's why network firewalls that filter traffic on the basis of port number are easy to get through. This is also the reason why many network traffic monitoring tools can be deceived. If port 80 is used for communications with the use of a protocol other than HTTP, monitoring systems may not analyze the data sent over it. Such data is either completely ignored or just a couple of the first characters from the data section get analyzed. That's why a program called Gnutella, which used to be used in peer-to-peer networks, added GET to the beginning of each data packet. The program, just as with many others, runs on port 80. Having come across such a piece of data, many network intrusion detection systems and firewalls didn't analyze the packets further. Thus, we know already what sockets are. Let's get back to the TCP. This stands for Transmission Control Protocol. The name means that the task of the protocol is to guarantee data delivery. If you transfer some data through TCP, even if you use an unreliable link and unreliable lower layer protocols, the client will get the data nevertheless. In order to achieve that, the TCP uses sessions to transfer data. Therefore, you have to establish a session first. This involves sequence number synchronization. Thanks to that, the receiver will be able to detect that some packets were lost. In such a case, the receiver may request data retransmission. Because TCP uses sessions for data transfer, it can guarantee successful delivery. Moreover, the protocol guarantees that the data is received in the same sequence it's sent. This is achieved thanks to the sliding window mechanism. The mechanism involves data buffer, and each packet contains the information about the offset and data flow that must be accounted for in the buffer. There are two terms connected with TCP. The most important is establishing or initiating a session. It's called handshaking. Usually it's implemented as a three-way handshaking. The next is transmission of packets through sliding window flow control. The second protocol used in the transport layer is called UDP, or User Datagram Protocol. This is a stateless, connectionless protocol, which means it does not guarantee successful data delivery. That's why UDP is used much less frequently than TCP. UDP is mostly used in local networks to transfer small amounts of data, which can fit easily into the Ethernet frame. This can include DNS server queries. The response is also so concise that it can be contained in one packet.